In this video we're going to make a parametric kitchen style door. First of all, draw your geometries as you want them, and then we can edit those geometries to make them parametric. Now, this is only available if your key has the parametric geometries enabled. So if you go to modify, and if this edit parametric geometry is dark as it is here, then you have that option with your key. If it's grayed out, you don't have that option, and so this won't be available to you. So click on edit parametric geometry. It says select a polyline. I'm going for the outside shape at the moment, and so where the red crosses, which is the top left at the moment, that is where this measurement here is related to. So I can go around each corner if I want and click it to each corner and say that is linked to, in this case, 0, 0, and then I can go to the next corner and that is top right, so that will be on there. If it is linked to the same all the way around, I can click on this icon here which says fixed distances to panel edges. If I click on that, that will automatically link all of the four corners in this case to that, so I don't need to click each corner. Click apply. If anything changes, then I know I've got something wrong. It's not, so click OK. And I want to make the inner shape parametric. So again, modify, edit parametric geometry, click on the geometry that you want to edit. Now I've already set this one up, but again, where the red crosses, that is where the that's where these measurements are pointing to. So again, our origin on here is top left. So here I could click just the top left here, but what I've already done is set up some local variables. So I've said the D edge, or the distance from the edge, so from the left side to the top left corner, is 50 millimeters, and I've set up HP1 is the high point up here, so from the top of the shape to the top of the door in this case is the 150. So to make these variable, I've put my X is D edge, so the distance from the left to this corner is D edge, the 50, and from the top down is the HP1. I can go to my next point, and on here this is an arc, and what I've done on here is made it so the radius of this arc is always a fifth of the dx, the width. So I put equals dx divided by 5 and then padlock that up. I've then left the rest of them unpadlocked so they can adjust as the panel shape changes, but I've said that the angle of the left angle here of this, as this arc comes out, is locked to 0 degrees, so that will stay there. The angle of this arc going out is unlocked, so that will change as it goes along. And what I've also said is that this has got to be a tangent to the next arc. Okay, so the arc radius is a fifth of the width, so the door changes, that will change, but the angle is always 0 and it's always a tangent to the next next line, next geometry. If I go to the next point, what we've got on here is that the top of this, or the finish of the this geometry, is half of the width of the door, so that's locked at dx divided by 2, and the distance from the top down, so the y measurement, is equal to d edge, and those two are locked on there, and we've said that it's always going to be a clockwise arc. The next point is the other half of this. These are all unlocked other than being a clockwise arc, but we've said it's got to be a tangent to the next geometry. And then the last arc here, this radius, it's similar to the one on the left. This radius is always a fifth of the width of the door. The distance from the edge is dx, so it's the full size of the door less the d edge, which we've got down here as 50. And the height of that corner, because we're measuring from the top, that corner down is equal to HP, or highest point 1. Again, we want that arc to finish at 0 degrees as it comes to meet this geometry. We can then go to the next point. So this down at the bottom right now, its x position is dx minus d edge. So whatever the width of the door is minus that 50 we've got as a d edge, and the length of the door, the bottom corner of this profile is the length of the door, so the dy, again minus that d edge. And the left corner, the x is d edge because we're measuring from the left, and the bottom is dy minus edge. And that's it, we've got 7 points on there. If we want to check anything as we go along, we can click apply, and if it does anything weird, then we can see what it's doing. So just as an example, if I change this value here, let's say it's going to be 75, and I say apply, you'll see that all of the shape changes. And if I say the arc is different, let's say it's 120, and I say apply, the arc will straighten out on there. Put those back to where they were. So we had 50 and we had 150 there. Apply. If we OK that one, we've now made that drawing of those geometries parametric to the panel size of dx dy. So if I go and change my size, let's go for a 396 and apply, the panel changes, the geometry is linked to the panel, so those will change. So these arcs will all have changed on there. Height wise will be the same, but it's not going to make a lot of difference, but we'll go down to 600 on there as well. So we have a parametric door on there. Save that one. We now want to apply machining. So if we're going to machine the outside, let's go for a cut path. Got the tool, outside clockwise is going to go once round to the full depth of the door. Click select, select the geometry, and that has put the machining on there. I may want to start somewhere different, I may want to lead in, lead out, but we'll leave that one for the moment. I may want to pocket the middle of this shape away, so I can go into pocketing. Again, I'll use the same tool on here. I want to go down to 6mm deep, start on the inside and work out, link it to the geometry, so that must be red if it's going to be a parametric one. Click select, click on my shape, and that will work out my pocketing machining on the inside. Maybe I want to have a conical tool to just put a slight relief on the corner, so I can go back into vertical mill. I can select my 45 degree. I want to go on the line. I'll go clockwise, and I want to go, let's say, 2mm deep. So if I click on there, click on that line, I've now got my machining there. Maybe I don't want to start right on that corner, maybe I want to start halfway across the bottom. So move start point, click where my snap is there, and when that's jumped to it, click OK. So if I may also want to lead in, lead out, so I can click on there, go to my data in and out. I want to lead in with a line that's going to ramp down. I want to lead out with a line that's going to ramp up, and maybe I want to go 20mm past the start point on the finish. OK that. So we can see our blue geometries there. If we look in 3D, this is our shape on here. Obviously, if we had a profile tool, we could be a profile around the door. Go back to normal view. So if we were in our panel description and we wanted to change this door size, let's say we wanted 500 now, 596, click apply. Because that's all parametric, all of that will change, giving us a different size door. So we'll go back to 3 on that one, and there. Okay, I'm going to save that onto my desktop, and then we can go into nesting. Before we go into nesting, if we wanted to modify any of those parameters, we can go to Modify, Drawing Variables, and in the local ones we have any variables that we've put in with a name. So I could go into here and I could say that is now 70 and that is 180. OK, that changes, and you see the machining change with it. So Modify Drawing Variables will allow you to change that, and the machining will go with that one on there. Go into Nesting, Tools, Nesting. I've saved that already, so I don't need to save it again. Go into Panel, Machining Panel, in Desktop, and somewhere in here I should have my drawing, arch door test, and I want one of that one. But if I copy this, so Control C, Control V, Control V, Control V, I can now change any of these door sizes as we go down. And we can have different heights as well if we want. Okay, so it's the same program, same drawing, which was parametric, but by changing the dx and the dy, that'll allow it when it's nested to be to alter the machining. Save the changes. I want 20 millimeters between the parts. I want 5 millimeters around the edge. It's a plain board, no grain, so I can have it rotating if I want. Click on the cogwheel, click OK, and then each of those lines in the Excel type nesting sheet will open, and you can see that the machining will jump to the size of the dx dy that we've put in as the door, and these will then nest them as they are there. So we have from one drawing with a parametric geometry using local variables, all of those doors now have come out with the 50mm around the edge and the 120 from the top, and from there we can output the program ready to run. I hope that's helped you understand local variables using parametric geometry. Thank you for watching.